Hi guys, so we are getting started on video number 2. Hope you guys are doing okay, and I also hope that we're doing okay with our pacing. Trying to keep your videos right around 10 minutes. I know ideally 5 would be enough. You guys know I can't do that. It's not in my nature. So we are now in video 2, and we're going to start talking about, if my document camera will focus, we're going to start talking about the concept of conditions and hypotheses for testing beta, which is known as the slope of our LSRL. And I know you guys can't see that, but here we are focused. Okay, so let's talk about conditions. Conditions, and I actually have this in your guys' notes, which you can access online. Everybody got copies of it. Checking the conditions, I've got 1 through 4 there. I had another little piece of lined notebook paper where someone gave me an acronym. Let's just kind of like talk it out a little bit. So if we remember the concept of our conditions previously on confidence intervals and significance tests, we know that we need to have random. SRS would be ideal, but that's not always possible. And I don't know why my document camera is zooming in and out so much right now. I apologize, but I can't do anything about that. We know that we need to have independence. And to be independent, we kind of have to wiggle room around that a little bit, but we understand that concept because we've talked about it so much. It needs to be linear. We are only playing with linear relationships, so a nice, good, relatively straight line in our scatter plot. This is not for curves. There is other stuff in stats land. We aren't going there. We got to focus on what we can do and what AP Board wants us to address. The rest of it gets to be a little bit funky, and so I'm going to walk you through some of the rest of these. So one of the things that we have to do is these are just so awkward. We need to make sure that this is approximately normal. And it's not our approximately normal that we are so used to seeing. Our residuals need to be approximately normally distributed. And you might be wondering, what does that mean? Well, I'm going to bring my book into the fold here, and I'm going to show you kind of like a visualized picture. And if you're wondering, hey, look, it's on page 592. Can you guys see the normal curves like pretending to jump out at you? The idea is we know our points are going to be scattered around this nice, bold kind of red-brown line, because scatter plots are not all going to be perfectly on that line. They're going to be scattered all over the place. Well, the idea is that we should see some normal variation of the residuals, the distance from the point to the line. They should vary normally around the line. So we shouldn't have any things that are like way far above and way far below. They should be normal around the line. Hey, just a sec. Hi, not right now. I'm doing a lesson. I'm sorry. We're going to just keep on going. So they should be normal around the line. I just forgot what I was doing, but I am not starting this recording again. Give me just a second. This is hard, you guys. And I'm sure it's hard for you guys too. I miss you. This sucks. So they need to be normal around the line. We also have to be able to state that the standard deviation, which is sigma, that we don't know, which is, we're going to talk about that more, has a constant scatter of points around the line. And that's really, really hard to show. So I'm going to be completely truthful with you guys. We can almost never, ever show that these conditions are met. And so that creates a problem because we're supposed to list our conditions. In my experience with AP Board and College Board and the testing that I have seen over the last, good Lord, I don't know how many years, They don't ask you to work through the conditions on these problems on a free response test. You might have a multiple choice problem where it might ask you something about that, because anything can be asked in multiple choice, but you're not going to be asked to address these conditions. If it's random, it'll state it. If it's linear, well, we can find out if it's linear. To determine if something is linear, sketch your scatter plot. Look at R and R squared. Does your LSRL of y hat fit the data? Just look, you'll know. For the normal, I'm going to walk you through that real quick. What we can do is something called a normal probability plot of your residuals. So the last thing that I ran was my linear regression. My residuals are good. If I go into second y equals, turn off plot 2, turn on plot 1, I'm going to go to L1 and resids. And that's second stat to get to resids. And instead of actually sketching them, I'm going to go up to my plot types. And by the way, when you go up to plot types, it'll give you the first one, arrow to the right, and it'll get you to the second line down. That bottom right sketch is our, oh, it just changed. Shoot. That bottom right, it's been a year since I've done this. Bottom right sketch is our normal probability plot. Just put in your resids there. That was second stat to get into lists. So x-axis, get out of that, go zoom 9. There might be a line shooting through here, but here's the deal. If the resids, I should say, if the normal probability plot of the resids is linear, then they are approximately normal. That's probably all we're going to be asked to address. There's nothing else we can show. There's nothing else we can do. Typically on an AP exam, what they're going to do is they're going to give you your data, and they're going to give you your scatter plot, and they're going to give you your y hat equals, and then they're going to ask you to go use it. So I need us to move forward, and we need to talk about our hypothesis options. And so this is for a hypothesis test, because I've got 2.5 minutes in my 10-minute video. We're going to have H naught beta equals 0. We are going to claim that there is no correlation between y and x. We're basically going to say that we have a chaotic scatter plot with a flat line around it. The other options for HA, we can do beta greater than 0, so that would be a positive correlation. We could do beta less than 0, a negative correlation. We can do beta not equal to 0, just that it's some type of correlation. So those are the options that we have. I'm going to stop this video here, and the next thing that we're going to do is I'm going to actually walk you through how to do a significance test and I just lost my train of thought, and a confidence interval for slope, which is B, but we're using beta because that's our parameter. So pause, here we go, just a sec, I'll be back.